systems of inequalities. When we solve a system of inequalities, we have more than one set of inequalities, 2, 3, 4, or more, and we're looking for ordered pairs that are solutions to all of the inequalities. The easiest way to do that is with graphing. Let's take a look again at how to graph an inequality. Graph 2x minus 3y is greater than 12. The easiest way to graph is to get y by itself. Subtract 2x from each side. Negative 3y is greater than negative 2x plus 12. Divide everything by negative 3. And we get y is, remember, the only difference between an inequality and an equation is if you divide or multiply by a negative, you have to flip the sign. Less than positive 2/3 x minus 4. As we graph this, we're thinking back to a simple equation of y equal mx plus b. We can see this line has a slope of 2/3 and a y-intercept of negative 4. So we'll put a point at negative 4. From there we'll rise 2 and run 1, 2, 3, 4. Rise 2 and run 4. We could also go down 2 and left 4. Now the line itself would be all the points that make it equal. But because there's no equal to on this, the points on the line don't make the inequality true. They're not solutions. So what we do is we dash or dot this line. Now I'm looking for all the y values that make it less. And it's as simple, remember, as looking at the y-axis. Here's where y is negative 4. Look at the y-axis, think of it as a number line. Which y values will make this equation true? All of these are less than negative 4, which tells you that all of these are the ordered pairs that if I plug them in this inequality will make the inequality true. If there had been an equal on this inequality, the only difference is the line would have been solid. Here's a system of inequalities. The thing you have to be careful about is your shading. And I'll show you how this works on paper. Our first equation, y is less than 3/4 x plus 5, has an intercept of positive 5 and a slope of up 3, 1, 2, 3 over 4. 1, 2, 3, 4. The points on the line that make it equal do not work, do not make the inequality true, so we do a dashed line. Because it is less than, we look at the y-axis, and all the smaller values are below on the y-axis, which means I'm going to be shading this way. Now, notice the way I'm drawing this. On paper, this is the way you do it. Because the actual solution is going to be the area that is double shaded, or triple shaded, or quadruple shaded. So we're looking for where all those lines will intersect. Let's try the next one. Y is greater than or equal to negative 2/3 x minus 3. The intercept is negative 3, and the slope is negative 2/3. I'll go down 2 and over positive 3. Down 2 over 3. Because there's an equal, the points on the line will make the inequality true, so I'll be drawing a solid line. Because it's greater than, I'm looking at the y-axis, thinking of it like a number line. I know that all the greater thans are above that blue line. So I'm going to shade one direction. Notice how we get cross-hatching. y is greater than negative 2 is y is greater than 0x minus 2, meaning the slope is 0. It's flat like the horizon, flat like the floor. And the intercept is negative 2. So we'll pass through negative 2 on the y-axis and have a slope of 0. There's not an equal to. This will be a dashed line. That line hits at negative 2. I'm looking for all the y's that are greater than negative 2, which would be above. Last one, x is less than or equal to 5. So this has no y. You can't solve for y. There is no slope. The slope is undefined. This is a vertical line through 5. Because of the equals, it is a solid line. I'm looking at the x-axis now. I'm looking for x is less than 5, which would be everything to the left of 5. What I'm looking for is the intersection of all those lines, the region that satisfies every inequality, which is this region right here. Any point I pick in that region, as long as it's not on the border of the dotted line, will satisfy every inequality and is a solution to every inequality. Here's some examples from your assignment. Y is greater than 1/4 x plus 1. This is nice because it's already in slope-intercept form. The intercept is positive 1 and the slope is up 1 over 4. Because there's no equal, it's a dashed line. Y is greater than, looking at the y-axis, these are the y's that are greater, so I'm going to shade above that line. Y is less than negative x plus 2, has an intercept of positive 2, and a slope of negative 1. So negative 1 over 1, I'm going to do down 1 and over positive 1. Down 1 over positive 1. Again, there's no equal. That means it's a dashed line. Y is less than, look at the y-axis. I'm going below on the y-axis for numbers less than where it hits. The crosshatch region is the solution. Y is less than 4x minus 3, has an intercept of negative 3 and a slope of positive 4, up 4 over 1. Because there's no equal, it's a dashed line. Y is less than, look where the line hits the y-axis. Think of the y-axis as a number line. These are the numbers less. So we're going to shade on that side of the line. Y is greater than negative x minus 5, has an intercept of negative 5, and a slope of negative 1. Remember, negative 1 is negative 1 over 1. That's down 1 and over 1 to the right. There's no equal. Again, it'll be a dashed line. Y is greater than. Look at the y-axis. Think of the numbers that are greater than where that blue line hits. Greater numbers are above on the y-axis. So I'll be shading on this side of the line. The actual solution, again, is the crosshatched region. Here are some equations with big numbers. I'm guessing that this will simplify a lot, so let's solve for y in both those equations. This first equation, we'll move the x to the other side, and we get negative 48y is less than negative 96x minus 384. And we'll divide everything by negative 48. Now remember, you're dividing by a negative, so you need to flip the sign. Negative 96 divided by negative 48 is positive 2, so 2x. Negative 384 divided by negative 48 is positive 8. For other equation, we'll move the 35x to the other side, and we get negative 35y is greater than negative 35x minus 245. Divide everything by negative 35 and flip the sign again. So y is less than x, positive x, and negative 245 divided by negative 35 is positive 7. For our first inequality, the intercept is positive 8, and the slope is 2 over 1, up 2 over 1. Or we could go down 2 and left 1. There's no equal, so this is a dashed line. Its y is greater than. Looking at the y-axis, greater numbers are up here. So I'm going to shade on the left side of the line. Y is less than x plus 7, has an intercept of positive 7, and a slope of positive 1. There's no equal, so again it's a dashed line. Y is less than. Look at the blue line. Less than numbers in the y-axis are below, so the double shaded area is this region. Any point from that region will make both inequalities true. Here's some inequalities with vertical and horizontal lines. X is greater than 3 is a vertical line through 3. It'll be dashed because there's no equal. We have to look at the x-axis for this one because its x is greater than 3, and every number to the right would be greater than 3. Y is less than or equal to negative 1, has an intercept of negative 1, and a slope of 0. It'll be a solid line because there's an equal. Every point on the line makes that inequality true. Y is less than. We're looking at the y-axis. Smaller numbers are below. The solution is the cross-hatched region. Again, any point in that shaded region will make both inequalities true. Here are a couple of inequalities in standard form. We need to solve for y to make this a little easier, so we'll move the x to the other side. That'll be 2y is greater than or equal to positive x plus 5, and divide everything by 2. There's a 1 in front of that x, and y is greater than or equal to 1/2 x plus 5/2. For the second equation, move x to the other side, and we get 5y is less than or equal to negative 2x plus 16, and we'll divide by 5, and y is less than or equal to negative 2/5 x plus 16/5. These fractions will make it a little bit of a pain to graph, but it's not bad on paper. I noticed that this question in WAMAP had you snap to grid, which didn't allow you to graph 3 1/5 for 16/5. So I actually pulled this question from the WAMAP assignment. But I'm going to complete it very quickly. The intercept is 5/2 for the top one. That's 2.5. So I'll put a point at 2.5 on the y-axis. From there, I'm going to go up 1 and over 2, up 1 and over 2. There's an equal, so it's a solid line. Its y is greater than. On the y-axis, greater numbers are above. So I'm shading above this line. Y is less than negative 2/5 x plus 16/5. 16/5 is 3 1/5, so that'd be just a little bit above 3. The intercept is down 2 over 5. It's a solid line because there's an equal. y is less than, shade below. So the crosshatch region is our answer. Anything in the shaded region there would make both inequalities true. This time we have a region that will be created by 4 different inequalities. These first two, we need to solve for y. We'll move the 2x to the other side. 3y is less than or equal to negative 2x plus 18. And divide everything by 3. And y is less than or equal to negative 2/3 x plus 6. For our second inequality, we'll move the 7x to the other side, and we get negative 3y is greater than negative 7x minus 12. Notice I'm subtracting 7x from each side. That's why the sign changes when we move it to the other side. We divide by negative 3. I'm sure they did that intentionally because you have to flip the sign. Y is less than 7/3 x plus 4. The first inequality has an intercept of 6, and it's a slope of negative 2/3. That's down 2 and over 3, down 2 and over 3. It's a solid line because it's an equal. Y is less than, we're shading below. For the second inequality, the intercept is positive 4, and the slope is up 7 over 3. Up 7 over 3 is actually off our graph. It'd be up here somewhere. But remember that 7 over 3 is the same thing as negative 7 over negative 3, because two negatives, when you divide, make a positive. So instead of going up 7 over 3, I could go down 7 and left 3. There is no equal on the inequality, so it's a dashed line. Its y is less than. The line hits at 4. Less than numbers on the y-axis are below there, so we'll shade to the right of that blue line. Y is greater than or equal to 0. Y equals 0 is the x-axis. Every point on the line works because there's an equal. Y is greater than, that's above on the y-axis, so we're shading above. X is greater than or equal to 0 is the y-axis. Notice the equal, so it'll be a solid line right on the y-axis. We have to look at the x-axis. Its x is greater than. Greater numbers are to the right on the x-axis. So to find the ordered pairs that make every inequality true, you have to find the intersection of all those regions. For this last example, we want to understand that the graph makes this so much easier. Because you could, if you wanted, plug those values in and see if they work. An easy one to do would be 0, 0. So you could go 2 times 0 plus 4 times 0 is less than or equal to 8. Does it make the equation true? Is 0 less than or equal to 8? Well, yes. That's a yes. But it has to work in both. So is 0 greater than 1/2 times 0 minus 3? Is 0 greater than negative 3? Yes, it is. So this is a solution. But doing the graphs makes this much quicker. To do the graph, the first thing we need to do is take that equation and solve for y. Move the 2x to the other side. 4y is less than or equal to negative 2x plus 8. And divide everything by 4. And that equation becomes y is less than or equal to negative 1/2 x plus 2. So the intercept is 2. And I'm going to go down 1 and over 2. It'll be a solid line because of the equal. Y is less than. On the y-axis, smaller numbers are below. My other equation has an intercept of negative 3. And the slope is positive 1/2, up 1 over 2, up 1 over 2. It's a dashed line because there's no equal. Y is greater is above on the y-axis. The crosshatch region is our solution. All those points make both inequalities true. The shaded region is the solution to the system of inequalities. So what we're going to do is check, is the point in the shaded region or is it not? It must be in the double shaded region to work for both. 6, -2 is right here. It is not a solution. 4, -6. 4, -6 is down here. It is not a solution. -4, +4 is on the line, so it would be a solution. It's on a solid line. If it was on a dashed line, it would not. -2, -4. -2, -4 is on a dashed line. It's right here. Dashed lines are not solutions, so it might work for one, it does not work for the other. Not a solution. -3, 3. -3, 3 just barely is in there. It is a solution. And 6, 5 over 6 up 5 is definitely not in the shaded region. It is not a solution.